Namaskar dear students. Today we are going to start a new chapter, that is Heron's formula. That is chapter number 12 of your textbook. It is used to find the area of a triangle when the lengths of three sides are given. So as discussed, we are going to use Heron's formula to find the area of a triangle when the lengths of its three sides are given. So before going further, let us first revise about triangle and its properties. As you are all aware that triangle is a three-sided polygon. It has three vertices, three angles and three sides. The sum of all the interior angles of a triangle is always 180 degree. And you have already studied in your earlier classes that the sum of the length of any two sides of a triangle is always greater than the third side. A triangle with vertices PQR is denoted by a small triangle sign and it is written as PQR. The area of a triangle is equal to half of the product of the base and the height. Also, let us revise the three types of triangles we have already studied. These triangles are classified on the basis of the length of their side. So if all three sides are equal, the triangle is called as equilateral. If two sides are equal, it is called as an isosceles triangle, and if no sides are equal, it is called as scalene triangle. Now revise what we mean by perimeter of a triangle. So as you are all aware that the perimeter of a figure is obtained by adding the length of its all sides. So in case of a triangle, there are three sides. So perimeter is the sum of all the measures of all its three sides. So if the sides of a triangle are A, B and C, so the perimeter is the sum of A, B and C. Always remember here that you have to include the units in the final answer. If the sides of a triangle are measured in centimeters, then the final answer should also be in centimeters. I have explained you the perimeter of a isosceles triangle, equilateral and a scalene triangle. In case of an equilateral triangle, all the sides are equal. So simply you can multiply the equal side, the measure of the equal side by 3 and you can get the perimeter. And in case of a isosceles triangle, you have to multiply the two equal sides by 2 and then add to the third side. And in case of scalene triangle, you have to find the sum of all the three sides. A small example to find the perimeter of a triangle. Why I am revising this topic? Because in finding the area by Heron's formula, you will require to find the semi-perimeter. So for finding the semi-perimeter, first you have to find the perimeter of a triangle. So here is a small example where the sides are given as 5 centimeter, 4 centimeter and 2 centimeter and you have to find its perimeter. So simply what you have to do, you have to add the sum of the three sides. So 5 plus 4 plus 2. So it is the answer is 11 centimeter. Let us see how to find the area of a triangle when the base and the height is given. Now all of you should remember that height is always perpendicular to the base. So the area of a triangle is half multiplied by the base multiplied by the perpendicular height. What will happen if the height is not given? So now let us find out what will happen to the area and how to find the area of a triangle where height is not given. Students, when the height is not given, that means the three sides of a triangle is given, we find the area by using Heron's formula. For using that Heron's formula, first of all, we find out the value of S. Now what is S here? S is the semi-perimeter. So I have already revised with you perimeter. Perimeter is the sum of all the three sides. So semi-perimeter is perimeter divided by 2 and the formula is under root of S, S minus A, S minus B and S minus C, where A, B and C are the lengths of the three sides of a triangle. So this formula is credited to Hero of Alexandria, who was a mathematician. Now let us see how to find the area of a triangle when its three sides are given using Heron's formula. Now there are only two steps. So in the first step we find the semi-perimeter denoted by S. So semi-perimeter we can find out by adding the three sides and then dividing it by the sum by 2. So 6 plus 8 plus 10, and then the sum will be divided by 2, that is 24 will be divided by 2. The answer, the semi-perimeter, will be 12 centimeter. And then we have to substitute the value of S, A, B and C in the Heron's formula. So it comes out to be under root of 12, 12 minus 6, 12 minus 8 and 12 minus 10. Now further we do the subtraction. We will get 12 minus 6 is 6, 12 minus 8 is 4 and 12 minus 10 is 2. And when we multiply, we get the answer as under root of 576. So remember that you have to revise the concept of square roots because it is very useful for this chapter. So under root of 576 is 24 and we have to write the answer. So it will be 24 units square. One more example with a triangle of sides 3, 4 and 5 feet. Now here the step 1 is to find the semi-perimeter. So we will add and we will divide the sum by 2. So 3 plus 4 plus 5, it comes out to be 12, and when we divide by 2, the semi-perimeter is 6. Then again we are going to substitute in Heron's formula. So it will come out to be 6 multiplied by 6 minus 3, 6 minus 4 and 6 minus 5. By further solving them, we will get the answer as 6 feet square. So the area comes out to be 6 feet square. Students, now let us recapitulate what we have learned in today's class. So we started with about revising the properties of a triangle. A triangle is a three-sided polygon, and we have understood how to find the area of a triangle when the length of its three sides are given using Heron's formula. And we are already aware about finding the area of a triangle when the base and height is given. So in Heron's formula there are only two steps we have learned, that first we will find the semi-perimeter and then we will substitute the values of semi-perimeter and its sides to find the area of the triangle. Now there is a very important point that when we find out the area, the last value may not be coming as a perfect square. Okay, so some areas can be in the form of irrational numbers, like they can be in the form of root 2 and root 3. So we are going to further see in the next class how to find the area of such triangles. Thank you.